to receive credit, you needed to underline the hypothesis, which is the part that starts after if. So that is, I make A's and B's on my progress report. The conclusion would be, I can go to the party. It doesn't always have to be given to you in if-then form. You still have to follow the rule. After if is the hypothesis. After the then or the comma would be your conclusion. All right, law of detachment says if P then Q is true, order matters. P has to come first and be true. Then I conclude Q is true. So the answer to this one was not possible. Because this right here is the first statement. This is the second statement. I can go to the party goes with Q. It did not follow the law of detachment. It had to state about making A's and B's first. Okay, so this was D, not possible. It's not possible to use the law of detachment here. It does not follow the law. You cannot assume just because you went to the party you made A's and B's. Okay. All right. Keyword bisects. You need to know that if it bisects, it divides it in half. It splits it in half, meaning you have two equal parts. I went ahead and labeled LMN green to show that that's the whole angle. That was 5x minus 23. Angle LMO. That's the angle in the interior adjacent to OMN. That was the x plus 32. But since I know these two parts are congruent, I could also add this is also x plus 32 if it's bisected. The value of, I circled what to find the measure of angle NMO. The measure of angle NMO was 61. So, it's gonna do that. So, there's more than one, there's more than one way to bubble in your answer choices. Does anyone have, I'm not going to be able to write. Does anyone have questions on how to get 61? Okay, what's your equation? What equation did you write? What's your equation? Yeah. What did you write? Okay, that's right. Alright, so you had to do two of, because you had to double them or add them together to equal the whole. That gave you 2x plus 64 equals 5x equals minus 23. You got x is 29, but that's not what they're asking. They're not asking for x, they're asking for the angle, so you have to plug it back in. Okay. Alright, so I need you to get out, this was the outline you got on Monday. I posted it again on Edmodo last night. I needed you to kind of start working on this and be ready to ask questions. I'm going to go over the outline and answer questions as we go through. Get out your test outline, please. First thing you need to fix, you're going to have 12 multiple choice questions and 10 open-ended. I've highlighted the key information already up here. You're going to have 12 multiple choice and 10 open-ended. I will add some notes to help you make sure you understand what to do. I want you to try the example test-like questions in the outline. So make sure a conjecture, that's like saying a statement or an educated guess. I spelled that wrong. Oh, I did it. I will expect you to do true or false. Give a counterexample. A counterexample is an example that proves false. When you have a false conjecture, it's false when the hypothesis, and I'm just going to abbreviate that, is true, but the conclusion is false. So whenever your conclusion is false, that's when you have to give an example that proves it's false. So I gave you two types of questions in the sense that one is asking, can you identify a counterexample from a given conjecture? And then, can you find a true conjecture? So, on this first one, which is the counterexample that proves the conjecture false? If two rays have the same endpoint, so two rays with the same endpoint is your hypothesis, then they are opposite rays. That is your conclusion. I want to find an example that proves the conclusion false. We should have H as my counterexample. Okay? Which conjecture is true? So you have to read each one. You might need to test it. That's the best way to determine if it's true or false, is to test the conjecture. So A says an even number plus 3 is always even. Yeah, that's false. I can test it. Even number 4 plus 3, that's 7. That's not even. Okay, B, an even number plus 3 is always prime. Prime means it's only divisible by 1 in itself. Okay, that's false as well. Do you have an example? Yeah, not 9. I'll give you 12. Or 6 plus 3, okay. 6 plus 3 is 9, and 9 is not prime. Okay? Alright, an even number plus 3 is always odd. Yep, there it is, true. Okay? True. Alright, then we have making sure you understand a conditional. That means that it will be in your form P, then Q. P implies Q, that's your symbol. The hypothesis, that is the P. That means it's everything after the word if. Your conclusion, I forgot to highlight that. Let me add that on there. The conclusion also you need to make sure you have. Your conclusion, that's the Q. And that's everything after then or the comma. If it's not there, it's implied. So, see if you can identify the hypothesis for the example. Read the test-like question. See if you can identify the hypothesis. All right, labeling helps me see. Okay, I'm looking for the part that's P. That is B. P is my hypothesis. Everything after the F to then. All right, then special types of conditionals. Converse, inverse, and contrapositive. Okay, what does the converse do to the conditional? Reverse or switch, okay, or flip, okay? So we have some type of switch or flip, meaning this should be Q, then P. Instead of P, then Q, or P implies Q, then we're going to switch it. Q, then P. What about an inverse? What happens with the inverse? It's a negation, a not, okay? That's when we have not. This is when we negate both. Make sure you negate both. So this would be not P implies not Q. Inverse is not P, not Q. Contrapositive. What happens there? If not Q, then not P. So what do we do for that? You switch, you flip it, and you negate. Okay? So for contrapositive, you have to negate and switch. Do both things. Okay? Alright, so 3, 4, and 5 are good test-like questions to make sure you can do converse, inverse, and contrapositive. I need you to try to do those right now if you have not done so. If you have, you can move ahead. Okay, so I just highlighted what would be the hypothesis and conclusion of each statement. Converse means I should have switched them. So we should have B here. Okay, if CD equals AB, then AB equals CD. For 4, we're looking for contrapositive, not Q, not P. So it's a negate and switch. That was C. And then on 5, we're looking for inverse, so we're negating both the hypothesis and conclusion. That was B. Okay. Any questions on those that type of problem? Converse, inverse, contrapositive. All right, 4. Inductive reasoning and deductive reasoning. Inductive uses patterns. You can have a number pattern or a picture pattern. Deductive uses, a rule or a fact. Okay. The first two you have here are examples of inductive reasoning. Using a pattern to find the next term or next picture or next number. So look at the pattern they gave you. Make a conjecture about the object in the next object in the sequence. What would it be? We should have B. Okay. Goes from 3 sides, 4 sides, 5 sides, so it has to be 6, and it has to follow gray, white, gray, white. Okay. All right. Make a conjecture about the next term in this sequence. Now we're looking at a number pattern. We should have C for this one. We should have C. All right, on the next page. Now we're going to look at valid or invalid conclusions using our laws of detachment. This, when I'm talking about my laws of detachment, that's deductive. Okay, deductive uses the laws, either detachment or syllogism. Okay, valid means that you can make a conclusion. Invalid means there is no conclusion. Okay, detachment. Let's just recap. If it's detachment, then we have to have P then Q to be true. Then we detach the parts, but keep the order. P is true, Q is true. Detachment, order matters. Order is important. Order matters for detachment. Now, if I'm talking about syllogism, okay, syllogism is when you have two conditionals. You have to have two conditionals. Detachment only has one. We're going to have P, if P then Q, and Q then R. Then I can say P then R. This is when we cut out the middleman. We need these two to be in common, same meaning, okay? And this is when we're going to jump from the first. Once they are in common, we can jump for the first to the last. So syllogism, we snake them together, cut out middleman. Okay, so they're going to tell you which law to use to make your conclusion. It doesn't always have to be given to if-then form. So like if I'm looking at my first one here, choose a statement that follows 1 and 2 by law of detachment. The first statement, number 1, right angles are congruent. I need to know the hypothesis and conclusion of this statement. What would be the hypothesis? Yeah, if the angles are right, so we're talking about right angles. Okay, what's the conclusion? Congruent, are congruent. Okay, so there's my conclusion. So I'm looking for P, then Q. If angles are right, then they are congruent, right? And the second statement says A and B are right angles. What is that pertaining to? Because we're saying right angles, that would be what? That's a P, correct? Okay, so using law of detachment, we're going to make the conclusion. Which answer choice is the correct conclusion? C. Angle A and angle B are congruent. Alright, so now we're going to use law of syllogism. Law of syllogism. See if you can pick out the correct answer choice using law of syllogism. Okay, so hopefully we go from P to R. We get C. Questions on this one? Syllogism means we're going to take out that middleman. So I'm going to take out this Q and go from P to R. If M is the midpoint of AB, my R is segment AM is congruent to segment MB. All right, biconditional. What phrase goes with biconditional? If and only if. All right, I can abbreviate that using IFF, symbolic, that's P double arrow Q. Okay? All right, so see if you can pick which statement, which is a biconditional statement of the conditional that's given. Your biggest clue is if and only if. H, we're done. Yes. Okay. All right, then we're going to make sure you know your properties. This is what we ended on the last 2 days. Addition, subtraction, multiplication properties, division properties of equality, okay? And then substitution property, reflexive. What is another way of thinking a reflexive property? Yeah, mirror, mirror image. Symmetric, what happens with symmetric? You flip or switch. And then transitive, what happens with transitive? Cut the middleman, okay? It's like syllogism. All right, guys. I want you to do our property questions. See if you can pick the correct answer choice. Justifying using a property. Flip or switch. Mirror image. Mirror image. All right, check your work. 15 was C, transitive. B is a symmetric, meaning they switch. Okay, here's a switch, guys. AB equals CD. I'm now going to switch them. So that means CD equals AB. That's symmetric. So on this one, it says GH is equal to FD and FD. Right there, the minute I start seeing, I'm starting with my conclusion is now my hypothesis. I'm starting on with the next statement. I see that they have that in common. So I'm taking out the middleman, and I'm not just going from the front to the end. So this is transitive, okay? Questions on identifying the property. Now, the open-ended part of this is going to be me stating the property and you completing the statement. So if I say, use substitution property to complete the following statement, and I say x equals 3, then x plus 3 equals what? And you complete the statement. What would x plus 3 equal? Use substitution to complete the statement. 3 plus 3, yes. Or 6, thank you, okay? You would have to use the property to complete the statement. Yes? I would take either one. 3 plus 3 is showing the substitution, and 6 means you did the substitution to get the value. Okay. All right, now, algebraic proofs. Okay, you will have an algebraic proof like this where you have to fill in the steps. Okay? The key to this is to pay attention to what happened from the first step to the next step, from the previous step to the next. So on the very first one, what's our reason for the very first thing? All right, it is given, okay? What they're saying here is 12x minus 6y equals 5 and x equals a negative 5. So look at what they did from the given to the next step. They yeah, they plugged in the negative. That's called substitution. Okay, so now I'm going to look from the previous step to the next step. From this negative 60 minus 6y equals 5, they got negative 6y equals 65. What did they do? Yes, they added the 60 to both sides. And this is the addition property. of equality. All right. Now, what happened next? Yep, division. Oops. Yes. How many do it? How many would I need to take off so you would do it? All? All? Two? Half? Okay. That would. All right. What happened from this step to this step? What did they do? We have. They flipped it. They put this here and that there. They switched them around. What is that called? Symmetric property. Nope, it's not a POE. Okay, next page. Next page. Okay. All right, guys. So I know mine's cut off a little bit, but I know it starts off telling you that angle 2 is congruent to angle 3, and then it says angle 1 and 2 are adjacent, and they make a straight line. Okay, so that's what I'm gonna start off with. Let's make our straight line, okay? And we're going to make 1 and 2 adjacent. So what should it look like if they're adjacent on a straight line? Yeah, but okay, what? Huh? Common side, yes. What would it look like? What pair? One coming from the vertex, going out. What is that? Obtuse and acute. Yes, obtuse and acute. Obtuse and acute. Now, what are these called right here? What is this called? A linear pair. We have to have a linear pair to start off with this, especially if it's on a straight line. A straight line is 180. Linear pair is 180. So we're just going to name them 1 and 2, okay? 1 and 2. Now, they've done most of the proof. We're just going to try to fill in the steps in between. So I'm just going to say, if I were to do what it says right here, angle 2 is congruent to angle 3, then my picture could also look like this, right? But instead of 1 and 2, if I substitute what it would be, 1 and 3, right? Because angle 2 is congruent to angle 3. That's one way of drawing it, okay? Or if I wanted to combine it all together, I'm not going to do that. That's just going to, we'll talk about that later. All right, so we're trying to prove that 1 and 3 are supplementary, okay? Angle 2 is congruent to angle 3. That was given, right? Then they said the measure of angle 2 is equal to the measure of angle 3. That's just definition of congruent angles. If they're congruent, they're equal, vice versa. So if I say they're equal, then I could also say they're congruent. If I say they're congruent, then I could say they're equal. So that's just defining what I mean by saying congruent. 1 and 2 are supplementary, okay? Huh? We know they're a straight line, right? Okay, and they're adjacent, so they are a linear pair. We knew this by a supplement. There's a thing called a supplement angle theorem, or we could say linear pair. I'm just going to write LP. When we do them, we knew they had to be a linear pair because they were a straight line, and that's 180. And what do we know about supplementary? What does it mean to be supplementary? They equal 180. So now I'm just saying measure of angle 1 plus the measure of angle 2 equals 180. That's the definition of supplementary. Okay? So look what happened between this line 4 to line 3. Said 1 and 2 equals 180, and then they said 1 and 3 equals 180. What did they do? They switched to 2 and 3. Why? How did I know they switched them? Because they're both congruent. So this is just substitution. Okay? Just substitution. Now, I'm not going to stress this. You'll have a word bank. It will be most likely with the segment. You're not going to do this. You're going to definitely have to be able to do, oops, where's it at? This. You're definitely going to have to do that. Okay? All right. This is the last section. You're still going to have to know your special angle pairs. Supplementary, complementary, linear pair, vertical. Okay. So right now I'm going to give you some time. I know this says if EB, right? This is wrong. This is missing the picture. That was copied wrong. Just X that out. There's 3 problems. There's 2 multiple choice, so there's 13, 14, and the one underneath that is open-ended. I'm going to give you some time to use your angle pair relationships to solve those. Okay, so 13 is wanting to identify the statement that is not part of the given for a proof. Not part of the given. If I'm trying to prove that the supplementary angles are perpendicular, then D is not part of the given. That's what we're trying to get to. Okay? It's not part of the given. All right, number 14. The measure of angle 1 is the 7x minus 5. Angle 2 is 5x plus 27. You should see that those are vertical angles, meaning you're going to have to do what to solve for x? Make them equal each other. 7x minus 5 equals 5x plus 27, so I think it was A. Okay. And then this is going to help you with your exit ticket. Please don't freeze up on me. Yep, it did. Okay, so maybe we'll do it. What? I got it. You need to write this down. 2 things could occur when lines intersect. Okay, 2 angle pairs are formed. Vertical angles and linear pair. Ooh, why are we put up? I know I'm still teaching. I'm working hard right now, so you should still be doing that too. So, based on the angle pair that you can use to solve it will determine if you're going to use vertical or linear pair. So like I have vertical across here. I have a linear pair, 2y plus x and x plus 40. But those are 2 different variables, so I don't want to start with linear pair. I want to start with vertical. So you solve for x here using the vertical angles. Using 2x plus 10 equals x plus 40. What is x? When you did that, you should have got x is 30. Now that I have x is 30, now I can plug it back in. 30 plus 40, that means this angle is 70, which means this is 70. So what does it have to be if I... Linear pair. Now I'm using linear pair. I can do 2y plus 30 plus 70 equals 180, or it's 110 because 70 minus 180 is 110. So I can say 2y plus 30 equals 110 and solve for y. Either way, you'll get the same answer. What is y? Huh? 20? Yeah, 40. Y is 40. Yes. It's just, where's it at? Where's it at? Oh. How do you do that with one's an x and one's a y? Can you use vertical angles here to solve this? Can you use vertical angles here to solve this? Can you solve 3y equals 12x? No. So what should you start with? Thank you. 6x plus 36 plus 12x equals 180. You're supposed to go check out. Give it to me tomorrow. But we cannot start with that. We have to start with the linear pair. Linear pair. Meaning 6x plus 36 plus 12x equals to 180. Now now I can have the same variables and I can solve for x. Anyone solve for x yet? What do we get x for? We got 8. Huh? Yeah, you do. I want y. Okay. So, yeah, subtract your 36. Yes, x. Isn't it 6? Hold on. Oh, yeah. 8. And then, yes, you solve for y. Exit ticket before you leave.